right, this question came from a practice, and while you can do it with calculus, I think the most efficient way to get it done in a match in under a minute is to use the calculator. So the best way to do that is to get a graph which fits it perfectly and then use the max and min command. And the key to that is taking this closed interval from 0 to 5 and starting with that on the calculator. So we're looking for maximum, minimum. Those are commands you can find, and I'll show you where to get to them in the calc menu here. But before you graph this, go ahead and set up the window. So go to Window, and then you want the x minimum to be 0 and the x max to be 5. So 0, and then arrow down there to 5. And don't change anything else. That's fine. It doesn't matter what these are. We're going to fix those in a second. If you then go to the y equals screen, you can type this function in. So 2x to the third power. Notice the cursor's up in the exponent. You arrow to the right to get out of that. Minus 15x squared, and this is the faster way to get a squared, plus 24x, and then plus 19. And when you hit enter, nothing happens. You have to go to the graph. Now, if I go to the graph right now, it's not going to be especially useful. I can see there's a minimum. I can't see the maximum. But instead of going from there, I'll do, instead of graph, just zoom. And if I zoom fit, you have to arrow down to get there, or you can memorize, I think it's 0. Yeah, you can just type the 0 or arrow to zoom fit and hit enter. And what it's going to do is make that window start at 0 and go to 5, which our graph had already done, but it's going to fit the y values to that. It's going to be perfect. Watch this. Oh, you can exactly see what you wanted to see. So what the calculator is doing is taking every one of the pixel x values from 0 to 5, which we told it to use, plugging those in and figuring out what y values go with them, and then setting the y minimum and the y maximum so that they fit. And it does that automatically, that zoom fit. Zoom fit is really only effective if you first set your x min and x max, and then zoom fit is going to be beautiful. Once you get to that, to find the maximum, that's calc. So we want to calculate something. So second calc, we want the minimum. I'll choose number 3 for that. And it asks you for a left and right bound. And you can arrow there, or you can just go, well, 0's got to be to the left, hit enter, and then 5 has got to be to the right. I know that's where I'm looking. And it'll guess, doesn't matter, just hit enter. If there's more than one maximum, guessing something close is a good idea, but just plain enter works fine. And it says the minimum is at this x value and this y value. The truth is it's really at x equals 4 exactly. There's a rounding error that can happen here. This is good to 3 or 4 significant digits. If you think about rounding it to 3 or 4, you'll get that that's 4. It happens when y equals 3, and we're looking for the value of the function. The minimum is 3. To do the maximum, second calc, maximum's number 4. I'll again do just 0, enter, 5, enter, and then enter for the guess, and it finds that the maximum is 14. Oh, that doesn't make sense, does it? It's showing me here, not here. You do have to pay attention. Let me try it again. Second calc. This is where the guess might come in handy. So if I choose maximum, left bound of 0, right bound of 5, and then guess of maybe it's around 2. There we go. It found the maximum is 30 at about x equals 1. So it's not, you can't trust all the digits on this screen when there's lots of them. You can trust 3 or 4 significant digits. And I think that's pretty handy. You can also make a table for this. Let me just go to second table. And you can see for the y I've got, it's showing me some y values. And somebody asked in practice, can you just check those numbers? No, I mean, maybe if you're sure it's in an integer, you can pick the biggest as 30 and the smallest as 3. But you can't be sure the questions are going to show that. So that's it for this video.